Ignition sequence start.
Good morning, and welcome to this look at the activity inside the International Space Station Flight Control Room at the Johnson Space Center in Houston. These specialists are keeping tabs on the proper operation of space station systems and assisting the Expedition 65 crew members with the final few tasks on their agenda for the day. Commander Aki Hoshide and his American, Russian, and French crewmates are in the midst of another week filled with activity. Along with their support of science research and station maintenance, they've completed a spacewalk outside the Russian segment of the station and are preparing for the arrival of a cargo ship on the U.S. side.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. This week, the first of 3 summer spacewalks took place and new science investigations are en route to the space station. On Wednesday, June 2nd, Expedition 65 cosmonauts Oleg Novitsky and Pyotr Dubrov ventured outside the space station to disconnect all external mechanical links between the Pierce module and the space station. This clears the way for the arrival of the new Russian multi-purpose laboratory module named Nauka, the Russian word for science. The undocking of the Pierce module is scheduled for later this summer. The next day, the launch of SpaceX's commercial resupply mission 22 began its journey to the International Space Station. Dragon will deliver more than 7,300 pounds of science, hardware, crew supplies, and other cargo to the orbiting laboratory. Science highlights include research that could help develop cotton varieties that require less water and pesticides, as well as a portable ultrasound machine. The spacecraft is also carrying the first of 2 solar arrays to be installed during spacewalks later this month. You can watch Dragon's arrival to the space station on Saturday, June 5th, starting at 3:30 a.m. Eastern Time on NASA TV. European Space Agency astronaut Thomas Pesquet worked on the Fluid Dynamics in Space, or Fluidics, investigation. The Fluidics investigation evaluates 2 aspects of physical experiments on fluid mechanics. The first aspect must analyze the liquid sloshing phenomenon in the tank of a spacecraft in microgravity. The aim is to improve the guidance and precision of satellites and to optimize their lifetime through better fuel management. The second aspect studies the wave turbulence phenomena that occurs at the surface of liquids. By observing this phenomenon in microgravity, scientists are able to focus only on the study of the liquid surface tension. The expected results could help to improve climate prediction systems and optimize the use of the ocean's renewable energy. That's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
The International Space Station is a laboratory in space where scientists can remove the constant of gravity from an equation in ways they just can't do on Earth. It's a trick that can be especially useful in natural sciences. For instance, researchers are working to learn how surface tension and capillary flow can be harnessed to improve systems for moving fluids in microgravity, like moving propellants in fuel tanks during space travel. By virtue of being 250 miles above the Earth and orbiting over different parts of the planet every day, the International Space Station provides a handy spot from which to gather data for a number of experiments that are designed to learn about the home planet of their creators. Here's a look at a number of those experiments, including the ones that involve astronauts with cameras in their hands.
Earth's climate is the product of many rich and complex systems. It's affected by water in its many forms, on land, in the air, in the oceans, and as ice. It feels influences from vegetation, from soil conditions, from the carbon cycle, from human impacts. We study and observe our planet's ever-changing conditions in many ways, from many locations. One location in particular provides a unique and powerful vantage point, allowing us to see our planet in high detail and on a broad scale: space. The International Space Station is home to many instruments that help with the study of our planet in a variety of ways. Each is an amazing resource for scientists and researchers, but together, they paint a picture of Earth richer and more detailed than any one instrument could provide. From the vantage point of the orbiting laboratory, JEDI measures Earth's surface vegetation, producing 3D views of forest height and structure and the surface topography beneath. Forests and other plant life respond to a variety of environmental stresses, and the EcoStress instrument allows researchers to study plant temperature and provides insights into how life on Earth responds to changes in water availability. OCO3 measures atmospheric CO2 with high accuracy, helping researchers better understand CO2 increases and decreases and the impacts of those changes. And through the use of two cutting-edge spectral imagers on the station, HISWI and DESIS, researchers have access to highly detailed information on materials across Earth's surface, from identifying minerals and rock types to distinguishing between plant species. There's another and often overlooked observational instrument on board the space station: crew members equipped with digital cameras. Over 3 million images have been collected by astronauts from the station, and those images can be put to a variety of uses. William Stefanov is branch chief for the Exploration Science Office, a part of the Exploration Integration and Science Directorate at Johnson Space Center. He says handheld cameras used by the crew act as a complement to the data gathered by the station's various instruments. And that comes down to the ability of the crew to take pictures that are panoramic and oblique versus a straight-down look. That panoramic view can be quite useful when observing natural disasters as they occur, such as wildfires or volcanic eruptions. Stefanov explains, a camera is an excellent tool for examining the plumes created by wildfires or volcanoes, because it gives you an immediate three-dimensional picture of what the plume looks like, what its structure is, and how far it's extending. The observational instruments aboard the space station provide science capabilities that are more than the sum of their parts. These instruments, along with photography from crew members, serve to keep a multifunctional eye on the condition of our home planet. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more eye-opening information about space exploration, visit science.nasa.gov.
Astronauts who do science on the International Space Station also spend some of their time helping explain scientific concepts to students on Earth who are studying the STEM fields of science, technology, engineering, and math. In this demonstration video, one-time station commander Sonny Williams guides us as astronauts Mark Vande Hei and Jeff Williams make use of the weightless environment to demonstrate Newton's first law of motion.
Sonny Williams, and I'm an astronaut who's lived and worked aboard the International Space Station, an amazing research laboratory that's orbiting the Earth about 250 miles above us. While we're at the space station, we astronauts live and work in a microgravity environment. Do you think the laws of physics will hold up in the space station while experiencing microgravity? Let's check with NASA astronaut Mark Vande Hei on the International Space Station to find out.
Newton's first law of motion says an object at rest tends to stay at rest unless acted on by an outside force. Also, an object in motion tends to stay in motion unless acted on by an outside force, like my finger.
Let's look at this from another angle. Over time, the International Space Station slows down from experiencing a very small amount of drag, or force, from a tiny amount of atomic oxygen in space. This is like the force you feel from the air if you stick your hand out of a moving car. Because of this, the space station does what we call a reboost. A reboost uses rocket engines to put a force on the space station. This allows it to speed up just a little to remain in orbit around the Earth. Let's join NASA astronaut Jeff Williams to check out what happens to the objects inside the space station when it begins.
Now the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually. And you can see I can float it here, and there's no reboost going on right now, so the camera's not going to go anywhere. It's just going to slowly drift due to the ventilation, or if I put any velocity into it, it'll drift out of the scene. But I'm going to try to hold it here steady, and you can see that it stays very steady. There's my camera. I'm setting it up for ignition. There it goes. It actually came a little bit early. Now watch the camera accelerate toward you. There it goes. I'm going to reach out and grab it and bring it back in the view here. And I'm holding it. I'm actually feeling the acceleration. I'm going to let go again. And here it goes. It's going to take off. I'll try not to let it hit you. Just going to miss you. Yeah, I'm going to let go now. And here I go, drifting back toward you again. So the acceleration applies to me too. Reached our 2.7 meters per second that we desired, and now if I let go of the camera, it's not going anywhere, so the burn is over. Reboost complete. We'll stay in orbit for a little while longer.
Can you use Newton's first law to explain why the camera began moving without an astronaut putting a force directly on it? I'm going to send you back to class so you can start to investigate this with the Classroom Connection found at nasa.gov/demonstrations. Thanks for exploring a little physics on the space station with us today. See you again soon.
Coming up next week, we'll get the astronaut lesson on Newton's second law. The science, the technology, the preparation for exploration still to come are all part of the program of more than 20 years of continuous human habitation on the International Space Station, and still counting. In that time, 244 different people from 19 countries have floated aboard and taken part in some of the more than 3,000 scientific investigations while getting humanity ready for future exploration out into the solar system.
This was once just a dream.
TTC go. TTC is go for launch.
2. Boost ignition and liftoff of Discovery and a team of explorers shaping their destiny.
An answer built by those who dared to ask. What if we were to channel humanity's knowledge and creativity into something truly revolutionary? What if we built a bridge between and above all nations? to jointly discover the galaxy's great unknowns, to endeavor to live and to work outside our planet for the benefit of all within. What started as an accord between two former rivals became a beacon of opportunity for the rest of the world.
We have ignition and liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space.
You ready for visitors?
We live this dream aboard the International Space
I
Station.
understand it's good to have you there and adjusting to your new home.
Adapting to life in space. It's been a process.
For the past 20 years, over 230 astronauts from all over the world have worked tirelessly together, boldly performing pioneering research and high-stakes spacewalks in the unforgiving environment of space. In this unparalleled orbital laboratory, circling the planet at 17,500 miles an hour, thousands of groundbreaking scientific experiments from over 100 countries have led to discoveries unachievable in the confines of Earth. From 250 miles up, an unbroken chain of residents have shared their view and their research with a generation eager to understand this higher plane. The space station is a symbol of humanity at its best, a shining example of international peace and collaboration in action.
3, 2, 1.
Endeavour, this is Houston. You've completed a historic ride to the ISS and have opened up a new chapter in human space exploration.
And as we turn our gaze outward still, this International Space Station is a living testament of our collective strength and perseverance, where our human curiosity prepares for the audacious efforts ahead. We continue to bridge the distances between us and prove just how much more is possible when we dream together.
NASA's Artemis program will expand on the achievements of the International Space Station and open the door for humanity to live and work sustainably on another world for the first time. First the Moon, and then the planet Mars. Actress Kelly Marie Tran tells the story of how we are going to put the first woman and the next man on the Moon in just a few years.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the Moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
America's astronauts come to the job from a wide range of backgrounds and experiences: test pilot, doctor, engineer, teacher. But one thing they all have in common is they've never been to space, not when they start. Like you and me, they each imagine seeing the Earth from space. Turns out that quite often, the reality of that sight is just not what they expected.
I had looked at pictures on social media and pictures in NASA archives of the Earth so many times, I actually started to get worried. What if I get up there and it's just like the pictures? I mean, that's going to be weird if that's the thing where I'm like, oh, it looks just like the pictures. I'm ready to go home now. And then on the Soyuz, my launch vehicle, I launched with the Russians. And on my Soyuz, when I first got a chance to look out my little window, which is about right here, at the Earth, there's something about looking out a round window at the curvature of the Earth that makes it just more pronounced and really makes it have a huge impact. I just had this feeling like I was way up high looking down, and we were over the ocean, and the blues that I saw, it was it was ridiculous. I'd never imagined in my entire life getting to see something that beautiful. It was so foreign for the human mind to look at that, to see that total black of space, to see the Earth highlighted that way. And then I got to see a sunset. I had one piece of paper, it had a picture of my kids on it and a few of my flight data file burn times on it, but I just took a pencil and I drew like 15 curved lines, and I just wrote light blue, darker blue, pink, purple, dark purple, all the way down to the surface of the Earth at sunset, because the scale of looking at a sun refracting through the atmosphere, it blew me away, and no picture captures that. There's no high enough dynamic range of a photo to capture what the human can see. So that first look outside completely sidelined me. I had a GoPro, and I made a recording to my brother of, no matter how much it costs in the future, come do this. You have to come do this. I mean, it's amazing. Over my 6 months in space, getting to look at the Earth every single day, it shows you something different. Every day it shows you that it's alive, it's a being just like we are. We're guests on this planet, and it's our mother, it's our father, it's our starship cruising around the sun in the middle of the solar system. There was never a moment that I looked out the window and didn't immediately grab a camera to take a picture of something that our planet was doing. It always surprised you, it's always magnificent. I'm a pilot, I'm not a scientist, I'm not a psychiatrist, I'm not a poet, but certainly when you're in low Earth orbit, looking down at the Earth, it doesn't matter if you're a physicist, a school teacher, a stay-at-home parent, or maybe you just backpack for your whole life. If you look out, you're gonna have a magical experience in your own way, for certain.
If you want another look at any of the stories you saw today, you can always find them on YouTube and Facebook, where you'll also find lots of other great features on a variety of NASA topics, so look around. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, our International Space Station panel discussions look into the future and consider how what we're learning on this station right now is building our ability to go back to the moon and then to send astronauts to Mars. Go to nasa.gov/podcasts for this week's episode and all the previous episodes. In fact, the full library of all NASA podcasts, which you can also find on Apple Podcasts, Google Podcasts, and SoundCloud.